Before we move on to actual stoichiometry, we also have to talk about types of chemical reactions. And although this is largely a review from Science 10, what I need you to know is that when we talk about chemical reactions, we're going to be talking about them in terms of one, identifying, but two, also being able to predict the chemical reaction that's going to happen. So before we get started, what I have to have you remember is that metals lose electrons, and because of that they form positively charged cations. Because they form positives, metals cannot bond with other metals. Instead, they bond with nonmetals or negative ions only in forming ionic compounds. Now on the flip side to that, you have nonmetals who gain electrons or electron density, forming negatively charged anions. Because of that, they cannot bond with other negative ions, but they can bond with metal ions in forming ionic compounds. They can, however, share electrons in forming non-metal bonds in covalent compounds. So what I want you to do here before we get started with the notes is make a chart. And no, I really want you to make the chart because it's going to make the comparison part for us a lot easier. I'll give you a minute to do that. So now let's start talking about the actual different types of chemical reactions. And the first one that we see is a synthesis. A synthesis reaction is most easily identified because when we look at its reactants and products, it has a characteristic number of 1. So when we look at reactants, generally there's 2. Usually one of them is an element, but there can be 2 or more reactants. The identifying factor is that when we look at the products, there's only ever one product. When it comes to predicting these kinds of reactions, the only kind that you would be expected to predict is if you have 2 elements, they must bond together in making one product compound. A general formula for this particular reaction is that A plus B produces AB. You take 2 individual things. Although those could be molecules, A and B could be a molecule, and bond them together into one single product. And an example of that is that we can have 8 irons bond with a sulfur octet to form iron 2 sulfide. Notice here that the subscript or the coefficients can be other than 1. You can have multiples of each group, but you only have one type of product molecule. If we're looking at an analogy here, this would be the example of the chemical marriage. You take 2 individuals and bond them together in one lasting product. Now on the flip side to that, we have decomposition reactions, and most people remember decomposition reactions because they know that decomposers are the worms and the slugs and the beetles and the flies, the maggots, they come along and decompose or break down stuff. So when we look at the reactants here of a decomposition, you have only 1. Where when we look at the products, now you have 2. So this is exactly the opposite of a synthesis reaction. And where a synthesis reaction had the general formula that A plus B produces AB, the decomposition reaction has the general formula that AB breaks down to produce A and B. Again, A and B don't have to necessarily be elements, they just have to be simpler materials than the initial reactant. So an example of that would be if hydrogen peroxide broke down to produce water and oxygen. Notice, like I said before, they don't necessarily have to be element products, but you do have to have only one reactant type. So where the synthesis was the chemical marriage, the decomposition is the chemical divorce. So you take one group and you split them up into simpler groups or individuals. Now this is where we have to start actually looking at the types of elements or compounds that are bonding, and that's where we start talking about a single replacement reaction. So when we look at single replacement reactions, the reactants are that you have 2 things, one of which is an element and one of which is a compound. On the product side, again, you have 2 things, one of which is an element and one of which is a product, or is a compound rather. When we look at the general equation, there's 2 different types. You can have that AB plus C produces AC plus B if C is a nonmetal, because C as a nonmetal will replace the nonmetal in an ionic compound. The second general equation, we have AB plus C gives us Cb plus A, where C, in this case, has to be a metal. Metals will replace metals. If you're trying to figure out whether or not a single replacement reaction will actually occur, we have to look at what's called the activity series. And the activity series is found on the front of your periodic table in the bottom right. And what we see is that elements that are at the top will replace any element below. All right, so that means that if you look at a reaction and you've got hydrochloric acid reacting with fluorine, fluorine being higher on the activity series will be capable of replacing the chlorine, which is below it in the activity series. On the flip side, if you had a reaction between zinc and hydrochloric acid, zinc being higher than hydrogen, because hydrogen here in the compound is acting as a metal, it's listed first. The zinc being higher in the activity series is able to replace the hydrogen. The reverse of that reaction wouldn't be possible because the hydrogen could not replace the zinc in zinc chloride because the hydrogen is lower than the zinc. So the synthesis reaction was our marriage. The decomposition was the divorce. This is where things get a little bit like a soap opera because the single replacement is our affair. We have a compound, a group bonded together, and a single individual element comes along. And that displaces or replaces one of the elements out of the original compound. So the next one we have to talk about is a double replacement reaction. And just like in the single replacement reaction, unfortunately now we have to again look at the types of things that are being reacted. So in the reactants we have two compounds. And in our products we have two compounds. With the general formula that AB plus CD produces AD plus CB. The A here replaces the C, which again replaces the replaces the A. Generally, when we look at these reactions, these happen in solutions when we have two aqueous materials that are actually largely dissociated and the ions are free to move around. In producing the product, one of the products is likely to be a precipitate, which means that it's likely to be a solid that's being formed. An example of that would be that potassium chloride and silver nitrate, both of which are soluble, they dissolve in water, produce silver chloride, a solid, and potassium nitrate. So the double replacement reaction has two couples, or two compounds that come together in a space, in a solution where they're able to interact. And what they do is they switch partners. These are the swingers of the chemical world. The last two types unfortunately don't have analogies to them, but they are easy to recognize as long as you are aware of the different kinds of materials that are there. So when we look at a combustion reaction starts with some kind of organic molecule. That's a carbon thing. Generally, it's something with carbon and hydrogen. And it reacts with oxygen gas. Remember that oxygen gas is a diatomic molecule. The products of this particular type of reaction are carbon dioxide and water. So an example of this is when we look at the breaking down of glucose in your blood, C6H12O6. It reacts with oxygen to produce carbon dioxide and water, effectively a combustion reaction. So it has the general formula that organic molecule reacts with oxygen, producing carbon dioxide and water. And an example we would see is if methanol reacts with oxygen, it produces carbon dioxide and water. The last kind of reaction that we see is called a neutralization or a water-forming reaction. It's actually very simple to do, but it's commonly mistaken as a double replacement reaction because people fail to recognize what the reactant molecules are. So when we look at the reactants, you have an acid, something with a hydrogen written at the front. reacting with a base, something with a hydroxide at the bottom. When the hydrogen and the hydroxide pair up in the reaction, you produce water and some kind of salt. That salt being the leftover ions getting paired together. So it has the general formula that acid, Ha, plus the base, BOH, produces Ba, the salt, and water. And an example of this we'll work through together when we do the lab. In class, we did happen to go through and predict a number of these reactions after balancing them. We also went through and predicted how, based on the reactants that you were given, you might end up with specific products. That's something you should give a try.